Now we're going to take a look at the associative property of multiplication. So this is, again, another property that we saw with addition. We said as long as you have all addition symbols between your any three numbers or any three symbols, you can change the grouping, right? You can change the association or where you put the parentheses in those numbers. So we could say that also holds for multiplication. So for any numbers, and you would need three of them, for any numbers A, B, and C, if I were to multiply A times B times C in that order, right, I'm going to do that in that same order on both sides of my equation, right? So I'm not changing the order. I'm not using the commutative property necessarily. So what I can do, though, is I can change my association. So on the left side of my equation, I'm just going to happen to put the parentheses around A times B, meaning to do that first. And then on the right side, I'm going to put the parentheses around the B times C, and that means I would do that part first. So this is going to be true that I'm going to get the same answers. I'm going to get equivalent things on both sides of the equation. And just to demonstrate that, I'm going to do this one where I've used the numbers 2 times 3 times 4. So you can see I've done the same thing, right? I haven't changed the order. Each one of these lists 2, then 3, then 4. But if I were to work out the left side of this equation, my order of operations says to do what's in parentheses first. So I would first do the 2 times 3 on this side. So that would give me 6. And so then I would still have to multiply that by 4, and that's going to give me 24. On the right side, if I do what's in parentheses first, since this time the parentheses is on the 3 times 4, 3 times 4 would give me 12. And so then I would do 2 times 12, but that also gives me 24. And this will work no matter what numbers you choose, right? So even though it works out a little differently, right? 6 times 4 versus 2 times 12, I still get the same answer in the end. And so we're going to actually use this with some pictures. And so how we would describe the picture is going to determine where the parentheses go in our picture. So if we look at this example, this could be like, I don't know, plates with squares with little hors d'oeuvres on it, or this could be like dice or something inside of a bag or something like that. But like imagine that we are wanting to find the total number of dots in this picture, right? So here's my whole picture. And what I really want to know is how many of these little dots are there, right? So how could I count that? Well, I would rather not have to actually count, right? I'd rather not have to go 1, 2, 3, 4, 5, 6 and keep doing it, right? So I'm going to look for a shortcut. So what this is suggesting is that we're going to use the numbers 2 times 5 times 3 in that order in two different ways in order to count the total number of dots. And of course, it should be equivalent in each expression that we do, right? So we're going to do this in two different ways, but they should both be equivalent because the number of dots should be the same no matter how I describe it, right? So it says the first way should first find the total number of boxes, right? So if you think about this, one way that I could count the total number of dots is first figure out how many of these boxes do I have, right? So these boxes that I'm saying, how many do I have? And again, this one's small enough, it's a simple enough picture, I could probably count, but let's think of a faster way. So a faster way is, well, I don't need to count all of them, right? Let me just figure out how many of these boxes there are in each circle. And so let's see, I've got 5 of them, right? So that's 5 boxes, and that's in each circle. So I'm going to say that's per circle, right? So then rather than going over and counting the number of boxes in each circle, I could just multiply that and say, well, I just need to know how many circles I have. And in this case, there are 2, right? So when I say circles, I mean like this and this, right? So that would be a, somewhat faster way, right, of finding the number of boxes, right? So notice that this is a multiplication problem. This would not be 5 times 2, it would be 2 times 5 because the circles in this case are the groups and the boxes in this case are the objects per group, right? And so that would tell me the total number of boxes. So if I found this first, right, that's going to give me the total number of boxes, but I'm trying to find the total number of dots, right? But once I know how many boxes there are, I can just multiply that by however many dots there are in each box. And so I just need to look at any one of the boxes and see, oh, there's 3 dots per box. And so really what I've done here is I've done 2 times 5 times 3, right? Except I've chose to do the 2 times 5 first because that would tell me the total number of boxes. So if I were to work this out, I would end up getting that there are 10 boxes, right? 2 times 5, 10 boxes, and then multiply that by the 3 dots per box, which means I would end up getting 30 total dots. But then another way I could think of this though is this, and so this is the second way. We should first find the number of dots in one circle. So rather than finding how many boxes we have, right? Let's just say, okay, let's not look at this one yet. Let's just look at this one and let's just count the number of dots in that circle, right? Now, again, I don't really want to have to go 1, 2, 3, 4, 5, 6. Like, I don't want to have to do that, right? So the faster way to find the total number of dots in this circle would be to just find the number of dots in each box and then multiply it by however many boxes we have, right? So I've got 3 dots per box. And I could multiply that by 5 boxes. So if I did that, right, and I would only have to count 1, 2, 3 and realize that they're all the same. So 3 dots per box. And then I just need to count how many boxes. 1, 2, 3, 4, 5. And so doing it that way, I would end up finding that there are 15 dots per box. I'm sorry, 15 dots, but then that's 15 dots, not per box, but per circle, right? And so really what I'm doing is I'm saying, okay, I'm finding this 5 boxes times 3 dots per box gives me 15 total dots, but that's not the total, that's actually the total per circle. And so then if I want to find the total, then what I would have to do is multiply that by my total number of circles. So then 2 circles times that number of dots per circle should give me my total. So this would be 2 circles times 15 dots per circle gives me, again, 30 total dots. It's just 2 different ways of thinking about it, right? So, you want to count the total number of dots and not have to actually count them. The first way was, well, let me just figure out how many I have in terms of how many boxes, right? So how many of these boxes do I have? And so to do that, I did 2 times 5, right? And then multiply that by the number of dots. The second way was, instead of figuring out how many boxes I have, let me just figure out the number of dots in one of my circles, right? So to do that, I did, okay, I've got 3 dots in each box times 5 of these boxes. So that means there's 15 circles, right? Or 15 dots inside that circle. And then I just multiply that just for however many circles I have, right? So it's just 2 different ways of looking at it, and both of them give you the same answer. And if you look at the 2 different ways, once you've written it out, you can see both of them are 2 times 5 times 3, but one of them has the parentheses around the 2 times 5, and the other one has it around the 5 times 3. Just 2 different ways. So let's look at another example.